In this setup, I am only using one transmitter on the ground. This demonstration uses the 7-channel Spectrum transmitter. I have linked two receivers to the same model on this transmitter. This is very important that both receivers be bound to the same model. So everything here in front of you flies, the servos, the XPO, and the two receivers. The secondary receiver in this case is the failsafe receiver. The wiring of this setup is very important. Here's a blown up picture of the XPO. Over here I have the master receiver. This is the receiver that I will be flying full time. Here are the corresponding servos that are communicating with the XPO, and here's the secondary receiver. This is just for power. You can connect the battery here. What is different about this setup is that the secondary receiver is the one that is controlling the XPO. On my two previous setups, I had the primary receiver also connected to the switch input. Since the 7-channel Spectrum transmitter does not have failsafe capabilities on the 7th channel, that is, programmable failsafe options on the 7th channel, we cannot automatically set it to give control to the secondary receiver. The PCM transmitter that I had before, I could actually program the failsafe to kick in on the particular channel being used as the switching input channel. The Spectrum transmitter only allows you to hold the last inputs that it received. This is not what we want. We want to have the ability to either have control automatically be given to the other receiver, or we want to have the manual capability to give control to the other receiver. This setup allows me to manually switch control to the secondary receiver should we observe loss of communication on the first receiver. Okay, here's the diagram again. So we're otherwise always flying this receiver here. The XPO is turned off and we're just flying the master receiver. Should you lose communication with the master receiver, you would know you've lost communication to the master receiver because the aircraft is no longer communicating with you. It's just stuck flying whatever orientation that it was last in, and now it's just on a dive or a bank or flying straight and level, and you're no longer communicating via this receiver. Since we have the control input, the switch input, to this receiver out here, this one, if it's still alive, which it should, okay, you would be able to then toggle control to this receiver. You would be able to turn on the XPO to then have the servos no longer listen to the master receiver, which is now on deadlock, and then the XPO will give control of the servos to the secondary receiver. Okay, so this is how it happens, and the whole system is set up. Right now the master pilot, which is the master receiver here to the right, is the one flying. Okay, and I have here the 7th channel on the secondary receiver going to the switch input. So the switching is actually being done by the secondary receiver. You always fly the primary. Should the primary fail, the communication to the primary fail, the secondary receiver is the one that's going to give control of the servos over to it. Here's the system being demonstrated. This is the primary pilot receiver here in action. We notice that the LED on board the XPO is not turned on. And now I'll give control to the secondary receiver. You notice you keep control of the vehicle always. Should you observe a lockout on the master receiver, the switching channel is being switched on the secondary receiver. I have demonstrated the control authority being shared by the two receivers on board. By toggling the control switch, the control path flips from the primary receiver to the servos over to the secondary receiver and the servos. However, in demonstrating this, all you are seeing is me changing a toggle position on the transmitter. Short of taking a hammer to the primary receiver, I can simulate failure by plucking out some cables. So let's do this. Here we have the primary receiver functioning, and then I will proceed to give control to the secondary receiver, and of course it functions as well. Now back to the master receiver. I'm going to pull out channels 1 through 6, the PWM signal of the master receiver. They're located right here. We quickly observe that channels 1, 2, and 3 are no longer on our control. Rudder is still in control, but the first 3 channels are not on the master receiver. Let's plug out the next set of 3 PWM signals. Now I have just removed the PWM signal from the master receiver, channels 1 through 6. The master receiver is no longer in control. So this would be simulating critical failure of the primary receiver on board the aircraft. So how can we save this airplane? Remember, channel 7 on the secondary receiver is the one that's going to trigger the XPO to give control to our redundant receiver. Here we go. And we notice we quickly have control of the aircraft once again. So I can safely land the aircraft and save it. I'm going to give control back to the master receiver. PWM signals are still plucked out. Okay, here we go once more. Let's give it back and save the aircraft. So we always fly with the primary receiver, and we only summon the secondary receiver in case we observe loss of communication to the primary receiver. I have simulated loss of communication by literally pulling out the PWM signals from the master receiver. The Spectrum transmitter, this particular one, does not allow me to program failsafe automatically to give control to the other receiver. It does not allow me to program channel 7 or 6 or 5 to automatically go to a preset position. The failsafe capability of this transmitter only holds the last valid inputs. So if the master pilot is flying and then you'd lose control of this, the vehicle would only hold the last inputs. This is why we give control of the switching channel to the other receiver. So only in the case of emergency you hit the switch and relinquish control to the secondary receiver. Otherwise you always fly this button released, not turning on the XPO, and you always fly the primary system. Happy flights!